Hello and welcome to another exciting Breakfast with Unity. This is actually the second time I did the intro today. The first time it didn't evidently take on YouTube, but it looks like we're doing okay now. Hopefully there won't be technical issues. Honestly, there's probably going to be more non-technical issues in this episode than technical issues because I said in the description we're going to be doing Rant, and we're probably not going to be doing Rant because it looks like it requires .NET 3.5. It's using some little things here that I haven't actually run into before. Okay, great. I can't get rid of that right now. So we get a whole bunch of errors just trying to import this in, and it probably is rewritable. I am going to check one thing. I just want to see if are we on the screen? Good. I just want to see if they have like a branch or something there that's actually .NET like 2 compatible. Where's my description? There it is. Bam. So the reason I want to do this on this episode is because we've been working on that Diablo-esque game, and I thought this engine would be actually really great for generating item names. Basically, it's a system for generating stuff using kind of fuzzy logic. Well, not fuzzy logic, but basically it just creates random. It's like Mad Libs, but you can just create Mad Libs anywhere and have them be very specific types of objects and stuff. So, let's see. There is a branch? No, there's just one branch. Okay, that's it. So yeah, I have a feeling that we're not going to get this running just today. So we're going to have to do something else. What am I going to do instead? Let's, have we done an audio visualizer yet? Is that something we've done? Yeah, let's do a basic audio visualizer. Basic visualizer. So, we're going to create a 3D object. We're going to create a sphere. We're going to make this sphere pulse to music that's playing. I'm going to go ahead and create a directional light. We're going to move the main camera so that it's centered. And we're just going to make this thing grow based on audio input. So we're going to need some audio. We've already got some songs in here from in context, so we're going to just grab one of those. What's the ones I like? Did I like this one? I don't know. This looks like it has good... the best ones to use for the technique we're going to be using today are ones that have a large range between peaks and valleys. So this looks like this would read pretty well. So let's go ahead and put this on our main camera. And we're now going to create a script called resize or change scale based on audio volume. I'm going to be very specific because we're not going to be doing the frequency distribution stuff on this one. This is just going to be a very basic synthesizer. All this does, sorry, not synthesizer, it's a very basic visualizer. All it does is it just takes the raw volume of whatever is happening on that frame and then puts it on the screen. We may do some smoothing and do some other things in a moment too, but we're going to just start with that, and that's all I'm going to promise on this episode at least. So public float, I'm going to make a float called Scale Boost, and I'm just going to default it to 1.0F. And what we're going to do is, it's actually very simple to do this. It's actually, Unity has really good tools for doing audio visualization. And that's why I figured it would be a good last minute change for an episode, and I think people will like it. So all we're going to do is we're going to be changing the transform.localScale. So transform.localScale equals, and we're going to be using audio listener dot get output data. So there's get spectrum data, get output data. Spectrum data allows you to break it up from into different channels. So you could have like the bass have a great effect on one object, and then have the treble have a great effect on another object, and they'll kind of move to the portions of the music. We're just going to be doing basic output data. This is just the raw sample value between -1 and 1. I think that's the range at least. Typically the values are smaller than that though, because you don't have just a lot of ones and negative ones in the actually no, it's not negative. It's just 0 to 1. I don't know what range it is. We'll play with it. So there's two versions of this. One of them is obsolete and deprecated. I actually like the deprecated one better, but let's, for the sake of using things, let's go ahead and use the one here. So we need to create a float array to store our samples. So float array samples, and we're going to pass in samples, and the channel is going to be 0. The channel is just the left or right audio channel. So this just means that we want samples. Oh yeah, and we have to set this size to what we want back. So I'm going to actually make this just one sized for right now. Samples, new float 1. So this will have a 1 element array, and all we're going to do is we're just going to pull that single element out and apply it to our local scale. Although we're going to, so this is a float, so this won't actually work as local scale. So we need to do vector 3.1 times that, and then we're also going to times by scale boost. And so this will give us, this is a vector that's one size. This will scale it based on the audio data, and this will give us a boost so that we can actually see what's going on with the music. So if we place this, oh, got a problem. Can't apply indexing to an expression of type void. Get up. Oh, sorry. So this is, again, this is, I was thinking about it kind of the other way. So hold on. Audio listener.getApp data. So this will fill samples with the data, and then we will just use, instead of that here, we will use samples 0. There we go. Save. Let's see if this actually works. So if we place this on our sphere and hit play, ooh, it looks like it's working. So we could adjust the size boost to make it so that it's more obvious. But we've already got a very basic visualization system running in just a few minutes, and we even messed things up a little bit. So, so this, as I said, is just giving whatever is happening in that frame on the audio, we're getting the volume of that represented by the size of the sphere. Since we have a few more minutes, I'm going to show how to do kind of a slightly smoother operation that will make this look... you saw how it was just kind of switching between sizes immediately. We can smooth this out by pulling more samples and then doing an average of those samples. So one of the things I like to do, I'm not sure if this is a good best practice, but it's something I've been doing and it feels pretty good, is right now samples, so we're used to 60 frames per second in games typically. Like there's some TVs that do more. I'm not saying that you can't do higher than 60, but 60 is like the usual standard. And we're not used to what sound is at. Sound has actually an insane resolution in seconds. In most audio that you hear, like a CD, if you put a CD in your if anyone uses CDs anymore, if you put an MP3, your MP3 is probably recorded at 44.1 kilohertz. What that means is there's 44,000 samples in 1 second. That's a lot. It's way more than 60. And so we can use a calculation. So we can do 44,100, and we can just let's see. So if we had 44,100 divided by 60, so we have 735 samples in 1 frame for audio. Our ears are actually incredibly high fidelity from a time perspective. It's pretty crazy. So so I'm going to use 735 as our magic number here, 735. And what we're going to do is we're going to do a sum of these things. So we're just going to do a quick for each, or actually I guess we'll just do a for loop. Actually, you can do for each. For each float sample in samples. And we're going to create a float average value equals 0.0f. Now what we will do is average value plus equals sample. And then after this, we will do average value equals average value divided by samples.length. So this is just a standard average calculation. So we're just averaging the 735 samples that happen in that frame, and then applying that to the frame. So let's see how this actually looks, and see if it actually makes things. It may not even make that big of a difference, but we'll see how it actually looks. So hit play. Let's get the size boost up a little bit. Yeah, it really actually doesn't look that different, does it? If we smooth that out over the course of several frames, though, it might actually. Let's just try. I'm just going to try a big value here, see what it does. This is obviously not hugely efficient, but it's also not. It's just ads, so it's not actually as bad as you might think. But if you can get away with smaller values are better for you. Actually, yeah, let's say this basic visualizer Unity, and we'll save this into our basic visualizer folder. Save, and hit play. Let's see how it looks with that larger value. Yeah, that definitely, no, it really doesn't make that much of a difference. Okay, who cares? But you could do this if you want to. I'm just going to go ahead and just make it a simple one value, and this'll. I'm just going to leave the rest of the code here. It's not going to hurt you any having it there. And if you wanted to change the values and play around with that, we'll cover spectrum data at another time. I think this is probably good for an episode. Sorry it wasn't rant. I'm kind of sorry it wasn't either, but at the same time, at least we got something. So, thank you very much for watching. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfyre. That's DRAKFYRE. And please donate. Cooking with Unity. Patreon.com/Cooking with Unity. Really appreciate your support. And you guys have a great one. I'll catch you tomorrow with another Breakfast with Unity.